Hello, friends. I hope you all are doing good. So, in this fifth unit, we will learn about model evaluation. In this, we'll try to understand how to perform model evaluation using Python and how to accounting for unequal error cost using Python. So, let's start our video. So, what is model evaluation? Model evaluation is a crucial phase in the data science process where you assess the performance of a trained model using various metrics. This helps to understand how well the model generalizes to unseen data and whether it can make accurate prediction or classification. So basically, we check the performance of the training model using metrics. This helps to understand the generalized form to unseen data and whether the machine can make accurate prediction or classification. Now, why model evaluation is important? First, it checks the performance of the machine. It allows you to measure how well your model is performing. Bias variance trade-off helps you detect overfitting, low bias, high variance, or underfitting, high bias, low variance. And then the model comparison enables you to compare different models and choose the best one. And after that comes business impact. In real world applications, good evaluation ensures that the model is both accurate and practical, leading to better decisions and outcomes. Now come the types of evaluation metrics. Evaluation metrics differ depending on whether you are working on classification or regression problems. Here are some common evaluation metrics used in data science. So, evaluation metrics basically differ on whether you are working on classification or regression problems. Here comes the classification models of the evaluation of metrics. These are models that classify data into predefined classes such as email, spam, or detection or sentiment analysis. The accuracy, the proportion of correct predictions out of total predictions. Then the limitation, accuracy can be misleading, especially for imbalanced classes, that is confusion matrix. A table showing the actual versus predicted classifications. The components are true positive, which is correctly predicted positive cases, true negative, correctly predictive negative cases, and then the false positive, that is negative cases incorrectly predicted as positive. And then come the false negative, which means the positive cases incorrectly predicted as negative. Then the precision, positive predictive value. It measures how many of the predicted values are actually positive. Then come the recall, which is sensitivity or true positive rate. Measures how many of the actual positives were correctly identified. And then comes the F1 score, in which the harmonic mean of precision and recall use when you need a balance between them. Then comes area under curve and ROC curve. The ROC curve is a plot of true positive rate recall versus false positive rate FPR. AUC, that is area under curve, measures the area under the ROC curve. Area under curve is better metric than accuracy for imbalanced data sets as it gives an aggregate measures of performance. Now we'll see how to perform model evaluation using Python. So classification evolution in Python. First, we are importing the necessary libraries, pandas, train test split, sklearn, random forest classifier, and confusion matrix, and the rest importance directories and libraries. Now we'll first loading dataset that is iris dataset. So we have created a variable data and load the iris, and we have created two variables x and y in which the pd.data frame data.data columns equal to data dot feature names, y equal to pd dot series data dot target. And then we have applied the train test split method, which is x train x test, y test. And we have used the train test split function in our data set x and y, and giving the test size as zero point 0.2 and the random state as 42. Now we are fitting the model by using the random forest classifier and the fit method in our dataset X and Y. And after that, making some predictions on the model on the X dataset using the Y and storing it in Y. Now we are evaluation of the matrix accuracy score function, taking parameter of Y test and Y prepared, confusion matrix, and then classification report, and then ROC and AUC. And after that, we are printing accuracy, confusion matrix, classification report, ROC, and score. Let us see the output of this code. As you can see that our accuracy is 1. The confusion matrix is 10, 0, 0, 0, 9, 0, 0, 0, 1, and the classification report according to the model evaluation has been detected. So see that accuracy, macro average, weight average, ROC, and score is 1. Now moving forward to the last topic of this video, which is accounting for unequal error cost using Python. In many cases, the cost of misclassifying one class may be higher than the misclassifying another class. Example, fraud detection, medical diagnosis. You can incorporate this unequal error cost into your model evaluation. Now, let us moving forward to the code of this using class weight to handle unequal error cost and using the fit method and passing the trained set of X and Y data set. As you can see, the random forest classifier has classed the weight in the random state. Now let's move to the conclusion part. Model evaluation is a critical step in the machine learning workflow, and Python provide numerous tools to assess the performance of both classification and regression models. When dealing with the imbalanced classes or unequal error cost, adjusting your evaluation metrics or using techniques like class weighting can ensure that your model is properly optimized for real-world applications where some errors are more costly than others. Okay. So I hope you understood the lecture. Thanks for watching.